This is the second code-focused video talking about analog signal. So I have on the screen here, and if you've paused it and read it or are about to, basically it's just talking about analog signal. So before we talked about digital signal, which was, there either is or isn't electricity. That's the core concept to walk away from. We're doing stuff based on the presence or absence of that electricity, nothing else. Analog is a little bit different because this comes into the question of, well, how much electricity? So the various kinds of Arduino boards will vary bit to bit, depending on how basically how powerful the processor is on that Arduino is kind of the short version of it. You'll have your chip on there, which if I pulled up the Arduino setup page, I've got it all labeled. You've got this kind of IC chip right here on your Arduino. And again, if you're not using an Uno, it's still going to be there, but it may be in a different spot. It may be a different chip. They do vary. But again, I'm going to be going forward assuming you have an Arduino Uno board. But here is the chip that is doing all of the stuff along with this one over here. They kind of work together and do some things. We don't need to get into the details of it, but basically this is the one that does stuff. This is the one that holds the data, if I've remembered that correctly, but they work together and they do all the bits and pieces. Hop into Arduino analog again real quick. But basically, the way it works is that the analog side of the board can detect variations in amounts of electricity in between 0 and 100%. In this particular case, because of the bit, I say the bit depth, we're not working in audio, but basically the computing power of the Arduino Uno, we have a total of 1,024 different differentiations of the that signal. So we can say, okay, in between no electricity and all electricity, there's 1,024 potential options for how much electricity is coming through. Because again, the computers themselves are digital, it has to go down to its base value of it either is or it isn't this much electricity. So it's defined into these discrete little subcategories of how much power we have on the pin. But we can utilize the map function to set that to whatever value range we need to work with. It's very useful. Again, if you're some boards are much more powerful and can have greater ranges to work with. Some are less powerful. It depends on the model of the board you're working with, but all Arduino Unos should be this range. And I think most of the Arduinos are, but again, there's some variances. The core of what we're going to be doing here is voltage dividing, which basically means we're going to send, these are all showing voltage dividers right here, but basically we're going to send power from the battery or the LED, not the LED, the computer or whatever. The power is going into the circuit and through a resistor. And then we're going to measure that voltage in between that first resistor and a second one before it goes to ground. All right, and these are just different ways we can arrange all of that. But basically, by changing the value of one resistor and keeping everything else the same, it will change what that voltage output that we're measuring is. And here's the math with it. You can calculate the thing. So, the voltage output is equal to the voltage input multiplied by, the one resistor divided by the other one and the chain. That's the math. So you can work out all of this and figure out what you should and shouldn't expect in terms of voltages. That's great. Whether or not you go into that in a lot of detail I'll kind of leave that to you as the teacher and the students, but this is the math involved to work it out. In order to see what's going on, we have a few special little sensors and components that we can utilize for that. And this is going to be a very broad statement here, but generally speaking, in the Arduino kits that you have things with these 3 pins, and you can't really see the 3 pins on this one because it's laying vertically, but this one also has 3 pins. But generally speaking, they will have a voltage divider built into it. The potentiometers here, they do, and these have little knobs, and basically you have the input voltage on one pin, if you see my mouse, and the output voltage on another. And then this is the pin here, this middle one that we're measuring. And as you turn the knob, basically it just moves a little piece of metal around in here, and it just creates more or less resistance that we can measure here on this middle pin. Again, that's a generic statement, but again, all potentiometers that I've ever come across have had it. So again, it's input and output, and then the middle pin is the one that you measure. They have different kinds of shapes and sizes. Sometimes they can be sliders. Sometimes they're exponential. Other times they're linear in terms of, resistance changes. It varies, depends on what you need. You got to see what comes with your kit. Also, it doesn't matter what direction it is. So if you turn your knob to the right and your numbers in your Arduino go down, you can just take the component out, rotate it 180 degrees, and stick it back into your circuit. It'll still work, just the direction is now flipped. All right, so to wire it up, we'll get into the wiring a bit later. Again, they're really straightforward, I think, in some code bits. But I just want to point out that, again, other types of potentiometers and things, you may have some pressure sensors. So as you press on different parts of the strip here, the resistance changes and we measure it. We may also have components with these 2 leads coming out, and basically these will work the same way. They're variable resistors, so again, they can change how much resistance they have, but they don't have that built-in fixed resistor to make the voltage divider in one component. So we'll have other things when we focus on the circuit video, and that will, but we have to add in that extra resistor in order to get it to work. There's a bunch of different kinds of sensors we can use, and we'll talk about all those in a bit more detail when we get into the circuit aspect of this. So let's talk about the code. The code is pretty straightforward. I still have this old one from the last video I just did. So let's just make a new one real quick. I'll make that bigger. And let's talk about what goes into the code for analog stuff. So we first have to tell the Arduino what pins we're looking at. So const int, just like before. And we'll say, I don't want to spell potentiometer, so I always abbreviate it to pot pin. My students always get a kick out of that, so I'll let you do that information, do whatever you want with that information. But we're just going to assign it a number. But because it's the analog pin, we have to add something to tell Arduino this is the analog pin, and that is a capital A. And then we have on the Arduino Uno, I think we have 6 pins, A0 through A5. So just A0, just like that. That'll work great. Because the analog pins on our Arduino are input only, let me find here. You'll see on the Arduino it says analog in. These pins only receive electricity. You cannot send electricity out the analog side like we could the digital side. So we don't have to use pin mode because these can only receive electricity. So if we hop back into here, we can set that up. And then we'll say, not const, int hot value, and I'm just going to say is equal to 0. And we can then go in and with our code, we just, like before, we look at the value. Pot value gets assigned analog read. Analog read functions just like digital read, except it is for the analog inputs. So we just say what pin we want to look at, the potentiometer pin, and we'll store that in a value, and we can do whatever we want with it. So for these, I like to do stuff with the serial port. So in our setup, we can say serial.begin, and for an Arduino Uno, generally having a value of 9600 is what we want here. The short version of this is what's called the baud rate. B-A-U-D is how they spell that. And it's essentially how many bits can get sent through the serial port every clock cycle when it sends stuff through it. So having a larger value means you can send more information through the serial port every time it sends stuff. This has its ups and downs. Basically, 9600 is actually a little bit on the lower end of what can be done, but this is what, again, the Arduino itself is not a very powerful computer. Modern computers have outpaced it since the early to mid 80s, give or take. So again, that's totally fine, because we don't need to manage a ton of info with the Arduino. The Arduino at its core is just, sending and receiving little electrical signals, and then we can use other computers that are more powerful to do stuff with that. So again, that's why we're picking this value. It's on a little bit of a lower range. It's just how much data gets sent. This is a good one for the Arduino's processing capabilities. So we can have that there, but you have to tell the Arduino to start that communication in setup, and then we can just say serial.print. I like to do serial.print line, and basically this just prints it and then does a carriage return when it prints it, so everything that you send has its own dedicated line. And this will function just like print or console log in P5. We just tell it what to print, and so, we could do things like, actually I'll do it like this, serial.print, and we'll say pot value there, and then we'll say serial.print line pot value, the variable, and I'll add a colon and a space for formatting things. So this will print out on the same line pot value colon space, and then it'll say whatever the number is, and then because this is a print line command, it will print it out later. So before, we had the LED and the light here, so we could go in and whenever we wanted to with a button, we could turn the LED on and off, and on and off, and on and off. But those were the only options. That is digital signal. It only has those two states. What's different about analog signal is that there's more than the two states. So normally, with what we've done so far with these digital pins here on the Arduino would just be able to tell whether or not there was any electricity on the system, or not on that pin, and then it could respond to it and do things. Over here on the analog inputs, and again, I've already done some of this in the last time I attempted to record it, so some of the wires are already in place. But in the analog inputs, there's differentiations between the minimum and maximum electricity. The way this works is the computer, still being a digital device, is taking in this data, and it's basically breaking up the voltages into little discrete categories. So if this was none of the voltage and this over here was all of the electricity, in between kind of my two fingers, there's a bunch of different little categories, so the computer can determine how much electricity is in there. The resolution of that, or the amount of those little categories we can put that into, is the bit depth of the computer. If you've ever heard of a 8-bit computer, and things like that, they worked with 8 bits of information, and stuff like that, and you get more and more bits down, we have more data. So this particular one here has 1,024 different different little categories it can break up that electrical voltage into. And that's kind of the core of the analog signal. So in order to be able to do anything with that, we have to take the voltage and divide it. And this is the core circuit-wise of what we will be doing here, is creating these voltage dividers. So basically the way the voltage divider works is that we have, I'll use this one and the second one here as the example, the flowing electricity. It's doing its thing just like normal. We have one resistor and a second resistor, and then in the circuit, and then in between them we are measuring that output voltage of the circuit. Basically, the resistors, because of all the math and the physics and how it's related, they are reducing that flow of electricity. They're causing resistance in the stream. But by changing one of those resistors, you can essentially have a expected output of this here. So I've got the math related down here. So if you measured that output voltage, you start with what you had and you multiply it by these things. But basically, as you change one of them, it changes that relationship for that output voltage. So again, by keeping a resistor and the normal voltage constant and changing the other resistance, we can change how much electricity is being sent to the Arduino pin, and then again the Arduino can respond to that. The main thing that we're going to use to help with this, at least starting out, is a potentiometer. I've got a picture here on the webpage of a few kind of common ones. We'll be using this one here on the right, where my mouse is, today when we start building the circuit. But they come in all kinds of shapes. Here's another one. Some of them are really small. You might need to stick a screwdriver in to turn it. Some of them are sliders, but they all do the same kind of thing. And that is voltage comes in on one side and comes out on the other. And then this middle one is connected to a variable resistor. And I think a good way to see that is for me to figure out where I put that potentiometer. Oh, there it is with the potentiometer right here. So let me get that in focus. And the way that this works is that, again, these two pins on the outside of your potentiometer are just connected to power and ground. But this middle one is connected to the wiper, which is what's connected to the turning or moving mechanism. And as you turn it, this wiper connects to more or less of a resistive material that allows more or less voltage to flow through the component. And on this particular one, you can kind of see it. Let me just kind of use the table here as a kind of a counterweight, but you can kind of see as this turns around, the wiper attached to the middle, and it's touching more or less pieces of the little metal right there as we rotate it. And that's the core of what's happening. Because the the resistance of everything else is set, this one here is changing, and we get that change in the voltage. So I've got some code here, and I've actually, because I, again, pre-recorded some of this, there's a little bit of differences between what we did in the code portion of the video and what's on the screen right now. So let me just explain what this code does real quickly. So we're monitoring the incoming electricity from the potentiometer, and we're going to use pin A0 for that, and we're going to be mapping it down below. That should be pretty normal. And then I've basically just imported the blink example and set that up to run on pin 8. So we'll connect the LED pin to pin number 8. We had to make sure, because it's a digital pin, we set it to be an output. The analog pins are only input, so we don't need to do that. We do all the mapping, and we're going to print it out and see it in the serial port so we can see it numerically. But I've also set it up so we can see this visually by also adjusting the blink code to, instead of being a second between each delay, it's whatever the value of that potentiometer coming in on pin A0 is. So let's hop over here down into the circuit. Now I've already put this code on the Arduino. It's already been flashed. So I've got all of this right here. We're going to ignore the LED to start with and just focus on the potentiometer and the serial port. So you can kind of see I've got this already set up. So we have something that it'll come from power on one end and ground on the far end. But the pin in the middle is the one that we want to measure, and that's the one connected by this yellow wire to pin A0 on the Arduino. So I'm just going to plug this in right here, making sure that they all line up. Just kind of mush that in there as best you can. And I am going to then go back into the Arduino app and open up the serial monitor. And if we click on that, it takes a second. But now, let me just decrease it a bit. There we are. So now what's happening? This is when we were printing that value. So every frame, the Arduino is going to look and see how much voltage is coming in and do all the mapping of those values with that map function I talked about in the code part of the video. And then it's going to send it via the USB port through the computer, and we can monitor it here. So the potentiometer is at about 17% of its total electricity. And you can see that there's that 178 is the actual number, give or take. It varies a bit, but as I turn this, I'll turn it towards me, so this will be clockwise. We've now dropped it all the way down to 0. And because of the code, it's going to slow down as I do this, but as I then increase it by turning it, in this case, counterclockwise away from me, you see that now the numbers are increasing, and the whole thing is slowing down because of some other parts of the code. But now we're at about, all of everything. So we're at 100% at a you can see that range of 1023 at the max, and I can turn it down a bit, and now it's about half. That's about half. And you can see that mapped value as well as the original value. So you can use that mapping to be pretty helpful later on with some other stuff. I want to point out one really useful thing with potentiometers, though, and that is that unlike an LED, the potentiometer doesn't care what direction the electricity flows through it. So maybe for whatever I'm doing, I would prefer it to be when I turned it clockwise, the numbers got bigger instead of smaller. So to do that, we can do a few things. I can either change which wire is going to positive or negative, or I could do essentially the same thing just by flipping the whole thing around. If I stick it back in there, we'll see that now I didn't touch the dial, but now we're back at 100%, and as I turn it now counterclockwise towards me, it's now going down. So you can orient this however you want it to. Now, again, to see this visually, because we're just storing this value in a variable in the code, and we're using that to affect the delay, we can stick this into pin 8, because, again, that's what was in the code, and then connect that to the LED. Get that back in there. I bumped it, and we can see that now this is blinking, and as I turn it one way, that delay gets lower, so it blinks faster. As I turn it the other way, the delay increases, so it blinks slower. So you can decide what you want. I won't go too nuts because I don't want to create any kind of, not great strobe effect, but you can get it going pretty fast. And in fact, that's going to be the core of the next portion of the video, is controlling it to blink so fast that we can't even see it blink. So that'll be the next topic that I'll talk about.
We'll get into that. But we can see these numbers coming in from the Arduino, and that's a really useful tool. The last bit I want to mention with the code is that we can do a lot of stuff with it. So we can go in and we can map some things. So maybe I wanted to say, in
I'll just call it mapped pot. And I like to give my things a default value to start with. And we can go into the loop and we'll say mapped pot gets assigned the map function. And here we can look at the pot value. That's the value we want to map. The original range, which is 0 to 1023. And then the new range. So maybe we want to go between 0 and 100. And now you'll have this new range, and basically it scales it. So whatever position it was in between here, it's now fitting into this one. So we can get a kind of a percentage value at the same thing. So I can go ahead and say, I'm just going to copy and paste this actually to save some time. But we can copy and paste this. And now instead of pot value, we can say pot percentage. And this will now be the mapped pot, like so. And I'm just going to do a serial dot a blank print line, just so that way there's a space in between these two things. So when we see it in the circuit in just a moment, that'll pop up there. So again, this is the core of the code. It's again, the code part is very simple. So one thing I want to do to kind of go with is this is a potentiometer. Again, it has a built-in, let me get that pulled out of there, a built-in voltage divider. A lot of components and sensors may do this, and you can usually tell the ones that have the built-in voltage divider because they'll have the 3 leads. This is very generally speaking. Again, I can't speak for every single, that reflection is annoying, component out there, but a lot of the sensors you'll use are just the resistor part that changes. You still have to build the rest of it. I've got a few of them here to look at. Right here, and you can see that they're still going to be analog devices, but they only have 2 leads coming out of it. I've added some bits to the end of this one to make it easier to stick onto a breadboard. But this one is a photoresistor, so as you shine more light onto this, the red portion changes its resistance, so it gets less resistive the more light is on the component. This one, the round one, is a force sensitive resistor, and as you push on it, it pushes around the little bit of liquid inside of there, so that way more electricity can flow. And a similar kind of thing with this one. This is like a bend sensor, so as you bend it, that resistance changes. I have more things in here, but these are some relatively common ones you'll run into. I have, like, this is a motion sensor. There's more photoresistors. There's a tilt switch. Other little buttons and sensors and things. You can find a lot of this online for relatively inexpensive. So if there's something you want to do, you can just find those components and go to town. So I am going to get another resistor right here. This is a 10K ohm resistor, the same one actually we used in the previous video with the button. And I'm going to set up this voltage divider. Because again, this doesn't have that built-in resistor of the potentiometer, so we have to adjust it. So I'm going to start over here, and we're going to have the same end result, but with different sensors. So I'm going to go with the force-sensitive resistor to start with. It's like a Jedi. So I'm just going to put it in right there. We're going to go to positive. It's going to go, again, through the sensor and out to that side. So we have to do 2 things. Again, if you remember from the diagram that I will put back on the screen as soon as I scroll back up to it, we have to have
two resistors and one of them changes. We already have the changing resistor here, so we're going to use this one, this 10k ohm, as a fixed resistor. So I am going to go out of the resistor into ground. I'm just going to use the same wires I used in the potentiometer for this, if I can get it into the hole. And we'll just do it like that. Get in there. There we go. Just like that. 10k to ground. But then we still need to measure between that, so we're going to attach that same end that we went to ground with to the resistor. So you see we've got the end of the force sensor that's branching off to the fixed resistor to ground and to pin A0. And I'm going to reconnect this LED back to pin number 8, and we should see that as I can't get this in there. There we go. We should see, yes, that as I press on this, the blink happens, and as I press it harder, it slows down, and as I let go, this should be going faster. I kind of press down. There we go. It's going faster. It's one thing to note, I pressed down on it vertically for a visual effect to kind of help you see that. That's not relevant. It's how hard I'm pressing the round bit is what it's measuring. I just wanted to point that out. And if I were to pull up the serial monitor, you can probably see this a little more clearly with the numbers. So as I press on this harder, it's at about 78%. So I go down, it's 60, 50, 30, 20. So it's not necessarily a linear scale. If you work with these, you may notice that it may be really responsive all at once, and then it kind of is less responsive with higher pressures. These things tend to be exponential in that resistor capacitance. Not resistor capacitance. It's an exponential scale on that resistance. It doesn't linearly move. You can find devices that do that though. I'm going to keep this setup the exact same. I'm just going to swap out what sensor is here. So this is that flex sensor, and there's one, doesn't necessarily have to be that way, I think, but I like having it set up there with the positive and negative. But you see it's blinking, and as I flex it a lot, it speeds up, and as I unflex it, it slows down. And maybe we go the other way. These particular ones aren't that, I'm not touching it, and it's just kind of at 42%. If I bend it back, it may kind of go down, but as I bend it forward, now it's going, it kind of maxes out there. These sensors I find are not the most reliable for super accurate sensing, but there may be uses for you to want to have some kind of bend or twist kind of measurement. So that could be a useful tool. I've now got the light sensitive one, the photoresistor, and we'll put it in there. And this is a pretty well lit area, but we'll kind of see if I bring this in and put it in focus for you. It's blinking a bit. I kind of got the light of my phone right on it, but if I cover this up, now it's going a bit faster because that light isn't going through my fingers. And then now it's slowed down. Now it's sped up, slowed down, and it's responding to the light. And again, the numbers on the screen are the same way. So those are the two kind of main ways we'll be working with the analog signal for now. Basically, by making a voltage divider, you can monitor what the incoming electricity is and have the Arduino respond to it. You can use whatever analog sensors you may have to have different responses. So again, it can be all kinds of different things. We've already made the Arduino do stuff with buttons. So you could utilize other aspects like maybe a joystick or again these other sensors to have your Arduino respond. It also doesn't necessarily have to be an LED. These just come across really well for lessons and recordings and like that for seeing the physical response. But any other various components you have in your Arduino kit, you could probably hook up to work. I know a lot of them come with a few little motors and things like that, so you could play around and see what works, combine different sensors with different output devices and see what is kind of cool. That's the main core of this. The next lesson we're going to hop into is kind of combining the digital and analog stuff into what's called pulse width modulation. And I've hinted at it already a little bit in this video. But I'm going to end it here, and hopefully for the next one, that tripod will have arrived. So we no longer have me holding the camera. It's all annoying. I'll have free hands. I'll have everything on the same screen at once. It'll be very, very nice. All right, then. I will end it now, and I will see you all the next time that I see you. Bye.